Static and dynamic behavior. Mechanical behavior under static and dynamic. The concrete slabs in the rigid behavior is one of the difficult applications due to plastic shrinkage. The pavement of concrete also noisy on road due to its young modulus and low viscous damping. The solution is the crack of plastic can be settled if adding a little bit of volume fraction of short polypropylene fibers. So in order to increase the damping properties of pavement of concrete is also by adding any elastomeric or bituminous product. By adding the WRT filler also in the tire will enhance the sliding wear resistance and make the modulus of the composites become decreased.
The addition of carbon black as reinforcing fillers not only changes the behavior, but also enhances the mechanical properties of rubbers compared to those without fillers. The first mechanical property mentioned is the tensile strength. Tensile strength is meant by how much a material can withstand when it is being stretched before it broke. We know that strain will increase as long as stress is applied, but rubber-filled carbon contribute to high tensile strength as it results in greater filler interaction. The second property is the hardness. Hardness is a measure of plastic deformation the material can reduce under influence of external stress. It can be proven that as the content of carbon black as filler increased, the cross-linking density increased. Thus, the rubber became harder.
Now I'm going to talk on abrasion. Abrasion results in volume loss, so by adding reinforcing filler to the matrix material improves the wear resistance of rubber. Furthermore, wear strength is influenced by composites hardness, which is an important factor in determining the quantity of material removed. Therefore, the higher the content of carbon black, the lower the wear rate. Hence, the higher the wear resistance of an automobile tire. The fourth property is resilience. Resilience is a measure of elasticity and is defined as the ratio of the energy returned upon recovery from deformation to the impact energy required to produce the deformation of rubber component. As carbon black increases, the resilience percentage increases, owing to two reasons. Firstly, carbon black interferes the rubber chains and limits their movements when they are stressed. Moreover, it shortens the long chains of rubber, results in the decrease in elasticity. As discussed earlier, the reinforced filler increases the hardness of rubber, hence giving it the maximum potential to absorb energy and minimum ability to return the energy in the form of kinetic energy.
Next, I will explain about the advantages of using composite materials. First, composite materials have high specific strength and stiffness, but at the same time it is also lightweight. This is a major concern for application in the aerospace and automotive industries. Second, composite materials is energy efficient. This is because it requires only small amount of energy during its manufacture. Third, composite materials are resistant to heat, corrosion, and external weathering. This makes them suitable to be used for application that includes exposure to harsh conditions. Fourth, it can be constructed from wide range of property according to the requirements of its final product. And lastly, composite materials can be shaped into any complicated or complex shapes.